Let's go to the next problem now. Now we have to show in this exercise that 4z union 5z is not a subgroup of Z. We know that if we record 4z alone, then 4z will be a subgroup of Z, because any mz is always a subgroup of Z. So 4z is a subgroup of Z. 5z is also a subgroup of Z. But 4z union 5z is not a subgroup of Z. So what will be the comment after I solve this exercise? We will comment that union of subgroups need not be a subgroup. So this is the main conclusion that we want to draw from this exercise. Now what is 4z? 4z, as you know, contains of all multiples of 4. So 0, 4, 8, 12 and so on. Minus 4, minus 8, minus 12, all positive and negative multiples of 4 means all 4z. What is 5z? It will contain all multiples of 5. So it will be 0, 5, 10, 15 and so on. Minus 5, minus 10 and minus 15 and so on. Right? Now I will take their union. So when I take 4z union 5z, I will put all the elements in one single set. And what is that set? So 0 will be there, 4 will be there, 5 will be there, 8 is there, 10 is there, 12, 15 and so on. If I look at the negative numbers, I will get minus 4 is there, minus, I am putting all the numbers together in one set. Minus 4, minus 5, minus 8, minus 10 and minus 12 and so on. So this is the set 4z union 5z. Now why this set cannot form a group with respect to addition? So we will start checking our usual properties, actions. What are they? Closure, identity and so on. So if I pick up any two elements of this set, is there addition again in that set? That should be the meaning of closure. So suppose I pick 5 and 8. So I'm taking 5 from this set. I'm taking 8 is also from that set. What is the addition of 5 and 8? The addition of 5 and 8 is 13. Is there 13 element in this set? No. This means that the closure will not be satisfied. So that's why once the closure fails, I don't have to really check all other properties. So what will I do in the solution? I will say it is not a subgroup because why? Because if I take an element 5 in the set, which is 4z union 5z, and let us take some other element in this set, suppose I take 8 in this set, which is also in 4z union 5z, then does 5 plus 8 belong to the set? Yes or no? So the answer is no. 4z union 5z, 5 plus 8, which is 13, does not belong to the set, because 13 is not there in the set 4z union 5z. So this means the closure fails. The closure action does not hold, and therefore I will not check any other properties of this set about group, and I will declare that this set 4z union 5z is not a group or a subgroup of Z. Now we will now take an example in which H is a subgroup, K is a subgroup, and H union K is also a subgroup. That example is very easy. You take H is equal to again 4z, and you take K is equal to 8z. Right? Now what is 4z? 4z is all multiples of 4. 0, plus or minus 4, plus minus 8, and plus minus 12 and so on. What is 8z? 8z is 0, plus minus 8, plus minus 16 and so on. Right? So if I take the union of these sets 4z union 8z, do you see that you will get 0? You will get 4 also in that set. You will get 8 also in that set. You will get 12 also in that set, because 12 is here. You will get 16 also in that set, and all these numbers will be. So who is this set? Eventually 4z union 8z comes up to be equal to 4z. Right? Now, so 4z union 8z is equal to 4z. So this means that, but I know that 4z is a subgroup of z. So my conclusion is that 4z union 8z is a subgroup of z. So it may happen sometimes the union can be a subgroup of z. For examples like this, the union need not be a subgroup of z. That is why the comment that we have made is now making sense, that if I take a subgroup h of g, if I take a subgroup k of g, can I surely say that it is not a subgroup? No. Can I surely say that it is always a subgroup? No. Sometimes it will be a subgroup, sometimes it will not be a subgroup. So that's why we are saying that H union K need not be a subgroup of Z. So this finishes our exercise.